Friends, in the last lecture we have started the new unit of this particular analytical chemistry method of separation. In that we have started the solvent extraction. We have seen the distribution constant and the partition coefficient, or so you can say the distribution coefficient. Then we are looking for the factors affecting the extractions. In that first factor we have discussed, that is a chelation. Chelation is nothing but the ring formation. Then now we have to talk about the process of the ion pair formation. Ion pair formation takes place when a reagent having large organic ion such as tribenzene ammonium ion or high molecular weight amines. This reagent combines with suitable metals containing iron to give a large organic solvent like ion pair. As compared to the solvation, solvent molecules are involved in the lone pair formation. The large ion extracting system lacks specificity because any relatively large unhydrated univalent cation will extract any such large univalent anion. Polyvalent anions have large hydration energy and hence they are not easily extracted. Chelating agent having two unchanged donor atoms such as 110 phenolphthalein from cationic chelate 110 phenolphthalein from cationic chelate complex, which are large and non-polar. Tris phenolphthalein ion 2 perchlorate gets extracted easily into chloroform, and extraction is virtually complete using large anions such as the long chain alkyl sulfonate ion in place of the hyperchlorate ion ClO4 minus. The extraction process can be given by the following equation. In general, it is written P3N organic plus H plus A minus will gives you the formation of R3NH plus A minus organic, that is a extraction, and that whatever the organic species is there, R3NH plus A minus plus B minus, it will replace the A minus, that is the anion extraction will be there. In the process of solvation, solvation is association of the solid molecule with the solvent molecule. In the extraction by the solvation, solvent molecules are directly involved in the formation of the ion association complex. Oxygen containing solvents like the ether, ester, ketone and higher alcohols have coordinating ability, which is important in extraction process. Such as a coordination solvent facilitate the extraction of the metal nitrates, chlorides by contributing both the size of the cation and resemblance of the complex to the solvent. Here example, N-tributyl phosphate TBP is widely used as a solvent in the extraction of the uranyl nitrate. Extraction of the Fe3 from strong hydrochloric acid solution in the aqueous phases exists as a chlorocomplex epicellopore in presence of organic solvent ether. The species extracted into ether as H3O R2O 3 plus FeCl4 minus. Organic solvents having dielectric constant less than 40 shows the appreciable ion association in it. Extractable species are formed with the neutral extractants having the donor atoms like the oxygen, sulfur, nitrogen, which can solvate directly the proton or the metal atom. Example, extraction of uranium by the ether and the methyl isobutyl ketone from nitrate solution. Then graph of percentage extraction versus pH, or the concept of the pH and its significance that we have to see. What is the percentage extraction? To analyze the sample, the amount of extraction in single extraction is more convenient because multiple extraction, though efficient, tends to be tedious. A relation between percentage extraction E and the distribution ratio is given by the following manner. Wi is equal to Vw upon V0 into D plus Vw into A. The amount extracted will be A minus W1. Therefore, A minus W1 is equal to A minus A in bracket Vw divided by V0D plus Vw. The fraction X of the original amount A that has been extracted will be A minus W1 by A. X is equal to A minus W1 upon A. X is equal to 1 minus W1 upon A. X is equal to 1 minus, you can substitute for the W1 upon A, the Vw divided by V0D plus Vw. Therefore, X is equal to V0D plus Vw minus Vw divided by V0D plus Vw. On dividing RHS by the V0, we get X is equal to V0D by upon V0 plus Vw upon V0 minus Vw upon V0 divided by V0D upon V0 plus Vw upon V0. It will gives you the form D. X is equal to D divided by D plus Vw upon V0. Percentage extraction E is equal to 100 into X. Therefore, E is equal to 100 D divided by D plus Vw upon V0. This is the percentage extraction. Percentage extraction depends on the distribution ratio as well as volume ratio of the two phases. Here we have to consider a metal Mn plus in the aqueous solution reaching with the chelating agent Hr in the same phase. Hr will dissociate as NHR will give you the NH plus Nr minus. Metal chelate will be formed as Mn plus Nk minus will be Nr minus will be equal to, it will gives you the Mrn, which can be extracted into organic phase. The distribution ratio is the ratio of the amount of the metal extracted as a complex into organic phase to that remaining in all forms in aqueous phase. That is, the D is equal to concentration of the Mrn divided by the concentration of Mrn W plus Mn plus W. Considering dissociation constant of the complex and the reagent as well as the partition coefficient of the complex and the reagent, the expression for the D can be written as log to the base 10 D is equal to log to the base 10 K plus NPH, where K is equal to K star is equal to K in bracket HR in the percentage of solute extracted is given by log E minus log 100 minus E is equal to log D is equal to log K star into NPH. The distribution of the metal in a given system is a function of the pH alone. When percentage extraction is plotted against the pH gives the sigmoid curves. The position of the pH axis depends only on the magnitude of the K star. The slope depends upon the N. Some theoretical extraction curves for the divalent are shown below. Then what is the pH hub? pH hub is defined as the pH value at 50% extraction. The above figure shows that how the position of the curve depends upon the magnitude of the K star. It also shows how the slope of the curve depends upon its N. pH hub is equal to minus 1 upon N into log to the K star. The difference in pH half value of two metal ions in a specific system is a measure of separability of the two ions. The pH half values are sufficiently far apart, then excellent separation can be achieved by controlling pH of extraction. Example, the data for the extraction of the metal dithiazonates in chloroform is mentioned below. Metal ions, copper, mercury, silver is given. pH for extraction is given. You can see that. pH of value can be altered to increase the selectivity of extraction by use of masking agent. If copper and mercury are to be separated by the extraction with the Dithiazole in CCl chloride pH2, EDTA must be added, which forms the water soluble complex, and mass copper and Ag can be extracted. These are the about the percentage extraction and the pH hub. Factors affecting the extraction that we have seen in that the first was the chelation, that is the formation of the coordination covalent, or say you can call it a dative, that a bond. Chelating ligand have a vital role in the extraction of the metal. The substance which brings about chelation is called as a chelating or complexing agent. That is the metal ion plus chelating agent gives you the metal chelate. The chelates are classified according to the type of the basic group present. If both the basic groups are unchanged, it results into positively charged metal chelate. If reagent has one anionic group, neutral chelates are formed. If there is a multiple negative group charge, the chelating agent results in negatively charged chelate. Neutral chelates are easily extracted into organic solvent. Aluminium ion in solution are usually converted into the hydroxyquinolate by the addition of the 8-hydroxyquinoline. The chelate form is extracted by using the benzene and the chloroform. Aluminium is only extracted at pH 5.8 in the presence of the iron, nickel and the vanadium. That is a given. At equilibrium is follows. At an equilibrium is as follows. NHK organic plus Mn plus aqueous gives you the MQN organic plus NH plus. The equilibrium is dependent upon the H plus ion concentration, hence the pH control is necessary. Other complexing agent or say masking agent are also used, such as the DMG, acetylacetone, kefferon, alpha nitroso beta naphthol and dithiazole. Acetylacetone form the special chelates with the more than 60 metal ions. DMG is used for extracting the nickel and palladium. The formation of the complex of metal ion occurs due to tendency of metal ion to acquire lone pair of electron from the ligands in its vacant atom, that is orbital of the appropriate energy and symmetry. It may be unchanged or it may be the uncharged or say charge space. The complex of the metal ion with the monodentate ligand H2O NH3 does not possess the ring structure. The complex of the metal ion with the polydentate ligand possesses the ring structure are called as chelates, which are more stable. This is underlined this. The complex of the metal ion with the polydentate ligand possesses the ring structure are called as the chelates, which are more stable. Anionic chelates are generally used as the sequestering agent to mask cation during the extraction. The effectiveness of the chelating agent to form the stable metal chelates depends on the electronegativity of the bond atom, the basic strength of the donor functional group, size and the number of chelate rings. Then we talk about the process of the ion pair formation that takes place with the reagent having the large organic ions such as the tribenzyl ammonium ion or high molecular weight amines. These reagents combines with the suitable metals containing ions to give the large organic solvent like ion pair. As compared to the solvent molecule are involved in the ion lone pair formation. The large ion extracting system lacks specificity because any relatively large unhydrated univalent cation will extract any such large univalent anion. That we have seen about this particular this reaction. You have to write about the ion pair formation. Process of solvation, that is nothing but the association of the solid molecules with the solvent molecules. In the extraction of by solvation, solvent molecules are directly involved in the formation of the ion association complex. Oxygen containing solvents like the ether ester, that is there, that we have seen already. Then we have seen the graph of percentage extraction versus the pH. What is the concept of the pH hub and its significance? pH hub is very much important as far as this extraction is concerned, because By knowing the value of the pH hub, we can there by knowing the pH hub, the extraction will be excellent, separation will be there, or extraction will be easy. pH hub values are very much important. You can see here the different examples are given. By knowing these values, you can alter the pH hub values, and we can selectively extract the particular metal by using the masking agent. Okay, please go through this part well. We will stop here. Thank you.